Now, in profiling, this is a concept, a basic concept in 2.5 axis machining. You have a start point where the cutter is going to start cutting. Now, this is where the cutting feed rate begins. This is the start of the cut, not the entry motion, but where the cutting starts. And for profiling, many times you will not profile a closed circle or a closed square. You may just have a line, okay? So you need to understand where the cut's going to start, which side of the line the cut's going to be on. And if you look at this top left dialog picture over here, if you're standing at the start point of the curve, if you look at the line here, it's got a little square box that shows you in the program where the start point is of that geometry. So if you picture yourself standing on that start point and you're looking in the direction of the curve, just use your right and left, and that'll determine which side of the cut's going to be on. If you select right side, it's going to be on this side. Left, obviously, be on the opposite side. It's all determined based on where the start point is. So if you have a closed curve, it's the same concept. Every curve has a start point. For instance, a circle has a start point in the program. And if you're going on the right side, you're going to be going, if you're facing the direction of the curve, the right will be on the outer side. In closed curves, you can select inside, outside as well. And just another, if you're just using a elliptical curve or any type of curve, again, start point, right and left. Now, if you look at this bottom picture here, if you have multiple curves in your geometry, for instance, in this picture here, we have 1, 2, 3, 4, 5, 6, 7, 8 curves, okay, and they're not merged together. So if you just select the 8 surface edges or curves, you will see that you got all kinds of start points, okay? So it's highly recommended that you join all of your curve geometry into a single curve. That way you know where the start point is of that merged curve. So that makes it a lot more intuitive for you, but it also solves a lot of potential problems. If you look up in this dialog in the top right here, these are some of the problems you can run into if you're not merging your curve geometry. You can have self-intersecting curves. You can have curves that touch other curves or that intersect or overlap curves, and that will throw an error in the program. It won't understand, how to process those curves if you have a curve on top of a curve, or if you have a curve partially on top of a curve or touching another curve. It could just cause a lot of complication. So again, clean your curve geometry up by merging it into a single curve. Follow that procedure by merging your curves. Understand that, double check that it is a single curve. You know where the start point is. That way, when you machine it, you understand which is the cut side, where is the start point, etc. And then also on the far right, that can cause problems if your curves don't connect. Your curves, if you're doing a continuous cut and you have multiple curves, you more than likely want those curves to touch end to end. So if they're not touching end to end, then you're going to end up with separate start points. You're going to have a gap in your cut. So just be aware, again, if you go through the procedure of merging your curve geometry and understanding that they are merged, it is one curve, you know where the start point is, all of these issues that you see in this dialog will go away. So you resolve those up front before you start the programming process and have to run into errors and whatnot. And again, a list of the common geometry issues that we just covered. Pay attention to the curve start point and the cut side. We stressed that a number of times on this slide. Always merge coincident curves into one curve. We mentioned that a number of times. Very important. Your curve boundaries, understand they don't have to be planar. If you have planar curves, that's great. Just select them. They don't have to be planar. If you have curves that are 3D curves or contoured curves, you can use those as well. Again, these procedures apply if you have three-dimensional curves. Make sure they're joined end to end, and you have a single curve, whether it's a contoured three-dimensional curve or whether it's just a flat 2D curve. The same principles apply. And then also understand that in 3D models, you don't have to have curves. You can use the edges of your surfaces as your curve boundaries.